There's something out there in the vast darkness of space that defies all logic, something so strange it makes even the brightest astronomers pause. Picture this, a galaxy with a cosmic black eye, a nebula shaped like a perfect ring, and stars that vanish without a trace. These aren't just figments of imagination, they're real, catalogued in the new General Catalogue, a treasure map to the universe's most bizarre objects. Hidden among its pages are celestial oddities so peculiar, they challenge everything we think we know about the cosmos. Today, we're going on a journey through 25 of them, each more mysterious than the last. What if I told you some of these objects shouldn't even exist? Stick around, because by the end of this, you'll never look at the night sky the same way again. Now let's turn our gaze toward the first object on our list, a galaxy that looks like it's been punched right in the cosmic face, the Black Eye Galaxy. Officially known as Messier 64, this stunning spiral sits roughly 17 million light-years away in the constellation Coma Berenices. At first glance, it appears graceful with swirling arms of stars and dust. But look closer and you'll notice something unsettling, a thick, dark band slicing across one side, giving it the appearance of a cosmic black eye. This eerie feature isn't just for show, it's a dense lane of dust and gas, absorbing light from the stars behind it and casting that haunting shadow. But the strangeness doesn't stop there. The Black Eye Galaxy harbors a bizarre secret. Its inner and outer regions spin in opposite directions. Imagine a whirlpool where the water at the center swirls one way while the edges twist back the other way. That's exactly what's happening here, and astronomers believe this cosmic contradiction is the result of a violent galactic merger. Billions of years ago, the Black Eye Galaxy likely collided with a smaller neighbor, sending shockwaves through its structure. The clash left behind this lopsided rotation like a ghostly fingerprint of the chaos that once unfolded. Adding to the mystery, the inner region is filled with young, blue stars blazing with intense energy, while the outer reaches host older, cooler stars. This stark contrast hints at a turbulent past where gas clouds crashed together, igniting waves of new star formation. So why does this matter? Because the Black Eye Galaxy isn't just a pretty face, it's a cosmic crime scene, giving us clues about how galaxies evolve through violent mergers. And while that dark band may look like a bruise, it's really a window into the universe's most dramatic reshaping events. Next up, we're trading the darkness for a celestial sombrero, one of the most iconic galaxies in the night sky. Leaving behind the haunting gaze of the Black Eye Galaxy, let's set our sights on something equally mesmerizing but with a far more elegant flair, the Sombrero Galaxy. Officially catalogued as Messier 104, this cosmic masterpiece earns its name from its uncanny resemblance to a wide-brimmed Mexican hat, complete with a glowing central bulge and a sharply defined dark dust lane encircling it like a decorative band. Located about 28 million light-years away in the constellation Virgo, this galaxy doesn't just catch the eye, it invites us to unravel its secrets one layer at a time. What makes the Sombrero Galaxy stand out is its structure. Unlike the chaotic aftermath of the Black Eye's merger, this galaxy presents a nearly perfect edge on view, showcasing its crisp, symmetrical profile. The bright central bulge is packed with older, yellow stars, giving it that golden glow, while the dark dust lane, a dense ring of cold gas and cosmic debris, wraps around it like a shadowy ribbon. But here's where things get even more intriguing. Nestled within that luminous core lies a supermassive black hole, one of the most massive ever measured. Weighing in at roughly 1 billion times the mass of our Sun, this gravitational monster influences everything around it, from the orbits of nearby stars to the intense radiation blazing from its accretion disk. Yet the Sombrero Galaxy has another puzzle up its sleeve, its halo. Most galaxies have halos, vast sprays of stars and dark matter extending beyond their visible disks. But the Sombrero's halo is unusually large and rich with globular clusters, those dense spheres of ancient stars. While our Milky Way boasts about 150 globular clusters, the Sombrero Galaxy has nearly 2,000, far more than astronomers would expect for a galaxy of its size. Why so many? Some theories suggest it absorbed smaller galaxies over billions of years, their clusters becoming part of this grand celestial hat. Others propose its unique formation history left it with this excess stellar bling. Either way, it's a mystery that keeps researchers guessing. So why does the Sombrero Galaxy captivate us? Because it's a cosmic contradiction, elegant yet enigmatic, serene yet hiding a voracious black hole at its heart. Its beauty isn't just skin deep, it's a gateway to understanding how galaxies grow, evolve, and sometimes defy expectations. And as we move forward, prepare to witness another galactic wonder, one where spiral arms dance in a gravitational embrace, shaping the universe in breathtaking ways. Now, let's turn our gaze toward a cosmic spectacle where gravity choreographs an interstellar ballet, the Whirlpool Galaxy, known as Messier 51. This dazzling spiral galaxy, located roughly 23 million light-years away in the constellation Canes Venatici, is a textbook example of celestial beauty and dynamic interaction. What sets it apart isn't just its perfectly defined spiral arms, but the fact that it's not dancing alone. A smaller companion galaxy, catalogued as NGC 5195, orbits it like a devoted partner, and their gravitational tango has shaped both into the mesmerizing sights we see today. Zooming in, the Whirlpool spiral arms are a masterpiece of cosmic design. Unlike the Sombrero Galaxy's orderly edge on profile, M51 is tilted face-on toward us, offering a front-row seat to its intricate swirls. These arms, glowing with vibrant blue clusters of young stars and pinkish star-forming regions, aren't static, they're dynamic, churning with activity. The secret behind their brilliance, the relentless pull of its companion galaxy. As NGC 5195 sweeps past, its gravity tugs on the Whirlpool's gas and dust, compressing them into dense clouds. This compression ignites the birth of new stars, turning the galaxy's arms into stellar nurseries where massive, hot stars blaze to life. But this dance isn't just creative, it's destructive too. The same gravitational forces that spark star formation also warp the Whirlpool's structure. You can see this in the asymmetry of its arms. One appears more stretched and distorted than the other, a telltale sign of the companion's influence. Over millions of years, this interaction will continue to reshape both galaxies, possibly leading to a full merger. For now, though, they remain locked in a slow, graceful waltz, offering astronomers a living laboratory to study how galaxies evolve through collisions and close encounters. What makes the Whirlpool Galaxy truly special is its role as a cosmic teacher. It was one of the first galaxies where Lord Rosse, a 19th-century astronomer, observed spiral structures through his telescope, revolutionizing our understanding of galaxies beyond the Milky Way. Today, it remains a favorite target for both amateur stargazers and professional researchers, its vivid arms and turbulent history providing clues about the life cycles of galaxies. As we marvel at this celestial whirlpool, remember, its beauty is more than skin deep. Every twist of its arms, every young star cluster, tells a story of gravitational forces and cosmic teamwork. And as we move forward, prepare to witness a far more explosive spectacle, one where a star's violent death left behind a nebula pulsing with eerie energy. From the graceful dance of galaxies, we now shift our focus to a cosmic remnant born from one of the most violent events in the universe, the Crab Nebula, also known as Messier 1. This swirling cloud of gas and dust is all that remains of a supernova explosion so bright it was recorded by astronomers in the year 1054. Imagine a star many times more massive than our Sun, ending its life in a cataclysmic blast visible even in broad daylight for nearly 3 weeks. Today, more than 950 years later, its aftermath still pulses with energy, offering us a front-row seat to the raw power of stellar death. At the heart of the Crab Nebula lies one of the most fascinating objects in space, a pulsar spinning at an almost unimaginable speed. This dense, city-sized remnant of the original star's core whips around 30 times every second, sending out beams of radiation like a cosmic lighthouse. With every rotation, it emits pulses of radio waves, X-rays, and gamma rays, which astronomers first mistook for potential signals from extraterrestrial life. This dizzying spin is a testament to the laws of physics. When a massive star collapses, its core contracts, speeding up just like an ice skater pulling in their arms. The result is a neutron star so dense that a single teaspoon of its material would weigh billions of tons on Earth. But the Crab Nebula's spectacle doesn't end there. Surrounding the pulsar is an eerie, blue-hued glow synchrotron radiation. This light isn't produced by heat like a normal star, but by electrons spiraling at nearly the speed of light through the nebula's tangled magnetic fields. The result is a ghostly shimmer that stretches across the entire nebula, illuminating filaments of gas that were once part of the star's outer layers. These filaments, rich in elements like helium and carbon, are the building blocks for future stars and planets scattered into space by the explosion. What makes the Crab Nebula truly unique is how much we've learned from it. Because its explosion was so well documented, astronomers have been able to study its expansion in detail, watching as the nebula grows roughly 900 miles every single day. It's also a cosmic powerhouse, emitting radiation across the entire electromagnetic spectrum, from radio waves to gamma rays. This makes it a key calibration source for telescopes worldwide, helping scientists fine-tune their instruments. The Crab Nebula is more than just a relic of destruction. It's a reminder of how death in the cosmos fuels new beginnings. The same elements forged in its explosion now drift through space, destined to become part of new stars, planets, and perhaps even life. And as we continue our journey through the NGC catalogue, prepare to encounter another cosmic wonder, a dying star's farewell gift to the universe sculpted into a perfect ring of light. Now, let's turn our attention from the chaotic aftermath of a supernova to something far more delicate, a cosmic jewel known as the Ring Nebula, or Messier 57. Unlike the Crab Nebula's explosive origins, this object is a serene yet profound example of a star's gentle farewell. Located in the constellation Lyra, the Ring Nebula is a planetary nebula, a glowing shell of gas ejected by a dying star in the final stages of its life. What makes it so captivating is its near-perfect symmetry, a luminous ring hovering in space like a celestial hula hoop. At the heart of this ring lies a white dwarf, the smoldering core of what was once a star similar in size to our Sun. As it aged, the star ran out of fuel, causing its outer layers to puff away into space. These expanding layers, now illuminated by the intense ultraviolet light of the white dwarf, form the nebula's iconic ring structure. But here's the twist: the Ring Nebula isn't actually a simple ring. Recent observations reveal it's more like a football-shaped cloud of gas, with the ring we see being the brightest part of its edge. If we could view it from the side, it would resemble a glowing barrel or a cosmic smoke ring. What makes the Ring Nebula particularly special is that it offers us a sneak peek into the fate of our own Sun. In about 5 billion years, our star will follow the same path, shedding its outer layers to create its own planetary nebula. The difference: our Sun isn't massive enough to explode as a supernova. Instead, it will quietly transform into a white dwarf surrounded by a glowing shroud of gas, much like the Ring Nebula. This makes M57 a cosmic time capsule, showing us what lies ahead for our solar system. The nebula's intricate structure also tells a story of its turbulent past. The inner regions are filled with knots and filaments, evidence of the star's final struggles as it ejected material in uneven bursts. These features are sculpted by stellar winds and radiation from the white dwarf, creating a dynamic interplay of light and shadow. The outer edges of the nebula, meanwhile, are expanding into space at about 40,000 miles per hour, gradually dissipating over thousands of years. One of the most fascinating aspects of the Ring Nebula is how its appearance changes depending on the telescope used. Through small telescopes, it looks like a perfect smoke ring. But with advanced instruments, the details emerge a complex, layered structure with subtle color variations caused by different gases. Oxygen emits a blue-green glow, while hydrogen and nitrogen create the red hues. This palette makes it one of the most photogenic objects in the night sky. As we marvel at the Ring Nebula's beauty, it's worth remembering that this cosmic masterpiece is fleeting. In astronomical terms, planetary nebulae are short-lived, lasting only tens of thousands of years before fading into invisibility. That makes M57 a rare and precious glimpse into a brief, dazzling phase of stellar evolution. And as we continue our journey through the NGC catalogue, we'll encounter yet another cosmic wonder. This time, not the death of a star, but the ancient gatherings of millions of them, bound together by gravity's unyielding grip. Moving from the delicate beauty of a dying star's farewell, we now shift our gaze to the crowded, glittering metropolises of the cosmos' globular clusters. These ancient gatherings of stars, bound together by gravity's unrelenting pull, offer a stark contrast to the solitary elegance of planetary nebulae. Among the most spectacular are the Hercules globular cluster, Messier 13, and the Great Pegasus cluster, Messier 15. These two celestial wonders may seem similar at first glance, but each holds its own unique secrets and surprises. Let's start with Messier 13, often called the Great Hercules Cluster. Located 25,000 light-years away, this dense ball of stars contains several 100,000 suns, packed into a region just 150 light-years across. To put that in perspective, if you were standing on a planet near its center, the night sky would blaze with thousands of stars brighter than Venus appears from Earth. But what really sets M13 apart are its mysterious propeller structures, three dark lanes slicing through the cluster's core, visible only through powerful telescopes. These puzzling features are thought to be caused by dust or the alignment of stars, but their exact origin remains a topic of debate. Now, let's turn to Messier 15, the Great Pegasus Cluster. While it's slightly smaller and more distant than M13, M15 is no less impressive. What makes it truly extraordinary is the presence of something incredibly rare, a planetary nebula nestled within the cluster. Known as Ps1, this faint, glowing shell of gas is one of only 4 planetary nebulae ever discovered in a globular cluster. Its existence challenges our understanding of stellar evolution, as globular clusters are home to some of the oldest stars in the universe, typically not expected to produce planetary nebulae. Yet there it is, a cosmic enigma hiding in plain sight. Both M13 and M15 are relics of the early universe, with stars estimated to be over 12 billion years old. To put that into perspective, these clusters formed when the cosmos was still in its infancy, long before the Sun or even the Milky Way's spiral arms took shape. The stars within them are metal-poor, meaning they contain very few elements heavier than hydrogen and helium, a telltale sign of their ancient origins. Studying these clusters is like sifting through the universe's oldest history books, offering clues about how the first generations of stars lived and died. Another striking difference between these clusters lies in their cores. M13 has a relatively loose, grainy core, while M15's center is so densely packed that astronomers suspect it may harbor an intermediate mass black hole. The gravitational tug-of-war in M15's heart creates a mesmerizing dynamic, with stars whirling around at incredible speeds. Some researchers even believe M15 may have once been a dwarf galaxy, stripped of its outer stars by the Milky Way's gravity, leaving only its core behind. Whether you're observing through a backyard telescope or marveling at Hubble's images, both M13 and M15 offer breathtaking views. M13, with its sprawling, symmetrical glow, is a favorite among amateur astronomers, while M15's concentrated brilliance and hidden nebula make it a treasure for deep sky observers. Together, they remind us that the universe's oldest structures can still surprise us, hiding mysteries in their ancient light. And as we continue our journey through the NGC catalogue, we'll encounter yet another cosmic neighbor, one that's on a collision course with our own galaxy. Leaving behind the ancient glow of globular clusters, our cosmic journey now brings us face to face with the grandest spectacle in our galactic neighborhood, the Andromeda Galaxy, also known as Messier 31. This colossal spiral galaxy, the closest major galaxy to our Milky Way, isn't just a breathtaking sight through a telescope. It's also on a direct collision course with us, hurtling through space at nearly 250,000 miles per hour. But don't panic just yet. This cosmic dance won't reach its climax for another 4 to 5 billion years, giving us plenty of time to marvel at Andromeda's mysteries before the merger. One of the most puzzling features of M31 is its double nucleus. Most galaxies, including the Milky Way, have a single supermassive black hole at their core. But Andromeda has two bright clumps of stars orbiting each other at its center, separated by just a few light years. Astronomers believe this odd arrangement is the aftermath of a galactic merger long ago, where a smaller galaxy was devoured by Andromeda, leaving its own black hole to waltz around the primary one. This gravitational tango creates a mesmerizing spectacle, with stars swirling in chaotic orbits around both nuclei. Then there's the enigma of Andromeda's distorted outer disk. Unlike the neat, symmetrical spiral arms we're used to seeing in textbooks, M31's outer regions are warped and uneven, as if someone crumpled the edges of a cosmic frisbee. This peculiar shape likely stems from past encounters with smaller satellite galaxies, their gravitational tugs pulling and twisting Andromeda's outskirts. Some researchers even suggest that the galaxy's outer halo, a vast, diffuse cloud of stars and dark matter, extends far beyond what we can observe, possibly enveloping our own Milky Way already in a faint, unseen embrace. Speaking of halos, Andromeda's is home to a staggering number of globular clusters, around 450, compared to the Milky Way's 150. These ancient star clusters, much like the ones we explored earlier, orbit the galaxy's outskirts like bees around a hive. But here's the twist: many of them move in unexpected directions, hinting at a violent past where Andromeda cannibalized smaller galaxies, absorbing their stars and clusters into its own structure. And let's not forget Andromeda's most famous claim to fame, its inevitable collision with the Milky Way. When these two giants finally meet, the night sky will transform dramatically. Over billions of years, the galaxies will swing past each other, their gravity distorting their shapes, before eventually merging into a single, elliptical galaxy some call Milkdromeda. Stars will be flung into new orbits, but the vast distances between them mean actual stellar collisions are unlikely. Instead, the real drama will unfold in the gas clouds, where compressed material will trigger a fireworks display of new star formation. For now, Andromeda remains a captivating target for stargazers. Visible to the naked eye under dark skies, it appears as a faint smudge of light, a glimpse of a galaxy over 2.5 million light-years away. Through telescopes, its spiral arms and dust lanes come alive, a reminder that even our closest cosmic neighbor holds secrets we've only begun to unravel. Now, shifting our gaze from the colossal Andromeda, we arrive at its smaller but no less fascinating neighbor, the Triangulum Galaxy, also known as Messier 33. While Andromeda dominates with its grandeur, Triangulum offers a quieter, more delicate beauty. Unlike its massive sibling, M33 is a petite spiral galaxy, roughly 1/10 the mass of the Milky Way, making it the third largest member of our local group. But don't let its size fool you. What it lacks in bulk, it makes up for in stellar activity and peculiar features that set it apart. One of the most striking differences is Triangulum's lack of a central bulge. Most spiral galaxies, including Andromeda and the Milky Way, have a bright, densely packed core of older stars. But M33 flattens this convention. Its nucleus is subtle, almost indistinguishable, giving it a more uniform, disk-like appearance. This absence of a bulge suggests a calmer galactic history, free from the violent mergers that typically sculpt such features. Instead, Triangulum's clean, open structure hints at a more isolated evolution, where gravity and time worked gently to shape its spiral arms. And what spectacular arms they are! Messier 33 is a hotbed of star formation, its spiral lanes dotted with glowing pink nebulae and young blue star clusters. One of its most famous regions, NGC 604, is a colossal star-forming nebula so luminous it's often called the Triangulum Galaxy's answer to the Orion Nebula. But here's the twist: NGC 604 is nearly 100 times larger than Orion, a testament to the galaxy's incredible generative power. These stellar nurseries are fueled by vast reservoirs of hydrogen gas, which Triangulum has held onto more tenaciously than its larger neighbors. While Andromeda and the Milky Way have consumed much of their gas over billions of years, M33 remains a bustling factory of new stars, yet Triangulum isn't entirely peaceful. Astronomers have spotted strange, lopsided distortions in its outer disk, likely caused by gravitational tugs from Andromeda. The two galaxies are close enough to interact, with Andromeda's immense gravity subtly warping Triangulum's shape. Some simulations even suggest that, in the distant future, M33 could become another casualty of Andromeda's appetite, merging with it long before the Milky Way does. For now, though, Triangulum orbits at a safe distance, a shimmering example of how even smaller galaxies can hold their own cosmic wonders. Through a telescope, M33 is a rewarding target. Its face-on orientation means we get a pristine view of its spiral structure, with faint arms stretching across the sky. Under dark conditions, keen-eyed observers might even spot its brightest nebulae without magnification. It's a galaxy that invites patience, revealing its secrets slowly, a quiet counterpoint to Andromeda's brilliance, but no less rich in stories. Whether you're drawn to its prolific star birth or its minimalist core, Triangulum reminds us that in the cosmos, size isn't everything. Sometimes the most intriguing tales come in the smallest packages. Now, as we turn our attention from the delicate spirals of the Triangulum Galaxy, let's venture into the haunting beauty of the Owl Nebula, also known as Messier 97. This cosmic spectre earned its name from the eerie pair of dark patches in its glowing gas shells, which resemble the hollow eyes of an owl peering through the darkness of space. But there's far more to this nebula than just its striking appearance. Nestled in the constellation Ursa Major, the Owl Nebula is a planetary nebula, the final gasp of a dying star, one that offers us a glimpse into the fate awaiting our own sun billions of years from now. The owl-like illusion is created by two distinct, darker regions in the nebula's outer layers, where denser knots of gas and dust block the light from the glowing material behind them. These eyes are sculpted by the complex interplay of radiation and stellar winds from the nebula's central star, a white dwarf that has shed its outer layers in a series of violent outbursts. What we're seeing is essentially the star's funeral shroud, expanding outward at tens of thousands of kilometers per hour. Over time, this expelled material will dissipate into the interstellar medium, leaving only the cooling ember of the white dwarf behind. Speaking of that central star, it's a fascinating yet elusive object. Once a sun-like star, it has now exhausted its nuclear fuel and collapsed into a dense, Earth-sized remnant. Despite its small size, this white dwarf is blisteringly hot, with surface temperatures exceeding 100,000 degrees Celsius. Its intense ultraviolet radiation lights up the surrounding gas, causing the nebula to glow with an ethereal greenish hue, a signature of ionized oxygen. Yet, spotting this star visually is a challenge even for seasoned observers. The nebula's diffuse structure and the star's faintness make it a tricky target, requiring dark skies and careful magnification to appreciate fully. And that brings us to the Owl Nebula's other quirk, its subtlety. Unlike some of the brighter planetary nebulae in the sky, Messier 97 doesn't give up its secrets easily. Its glow is faint and spread out, meaning light pollution or even a bright moon can render it nearly invisible. To truly see the owl eyes, observers often need telescopes with larger apertures and specialized filters that enhance the contrast of the nebula's delicate details. Even photographs struggle to capture its full complexity without long exposure times, as the outer shells of gas are incredibly tenuous, fading gradually into the blackness of space. Yet, for those who take the time to seek it out, the Owl Nebula is a rewarding sight. Its ghostly shape and the story it tells of stellar death and rebirth make it a favorite among deep sky enthusiasts. It's a reminder that even in its final acts, a star can create something breathtaking, a fleeting masterpiece of light and shadow. From its enigmatic eyes to the whispers of its fading glow, Messier 97 invites us to ponder the delicate balance between creation and destruction in the cosmos. And much like the owl it's named after, it seems to watch us in return, a silent sentinel of the night sky. Now, let's shift our gaze from the haunting glow of the Owl Nebula to a pair of cosmic wonders that defy expectations: the Dumbbell Nebula and its smaller counterpart, the Little Dumbbell Nebula. At first glance, their names might conjure images of simple fitness equipment, but these planetary nebulae are anything but ordinary. Each tells a unique story of stellar demise, sculpted by forces far more dramatic than their whimsical nicknames suggest. First up is Messier 27, the Dumbbell Nebula, one of the brightest planetary nebulae in the sky. Its hourglass shape, visible even through small telescopes, is the result of a dying star expelling its outer layers in opposite directions, creating a symmetrical structure that glows with vivid hues of green and red. The central star, now a white dwarf, bathes the surrounding gas in ultraviolet light, causing it to fluoresce like a cosmic neon sign. But here's the twist: despite its name, the Dumbbell Nebula doesn't actually resemble a dumbbell. Early observers, limited by simpler telescopes, saw only a vague, elongated form. Modern instruments reveal intricate loops and knots of gas, a far cry from the simplistic shape its title implies. Then there's Messier 76, the Little Dumbbell Nebula, a fainter but no less fascinating object. Unlike its namesake, this nebula lives up to its title even less. Instead of a dumbbell, it displays a bipolar structure with two distinct lobes of gas ejected at high speeds. These jets, racing outward at hundreds of kilometers per second, create a haunting, butterfly-like silhouette. The central star here is also a white dwarf, though it's shrouded in dust, making it harder to spot. What makes Messier 76 particularly intriguing is its asymmetry. One lobe is brighter and more extended than the other, hinting at a turbulent past where the dying star's ejections were far from even. The names of these nebulae, while charming, are a reminder of how early astronomy relied on rudimentary tools and interpretations. Observers in the 18th and 19th centuries did their best to categorize what they saw, often assigning familiar labels to otherworldly phenomena. Today, we know these objects are far more complex stellar remnants caught in the act of transforming, their shapes dictated by magnetic fields, rotation, and the chaotic dance of escaping gas. For amateur astronomers, both nebulae offer rewarding challenges. The Dumbbell Nebula is an easy target for small telescopes, its vivid glow standing out against the black of space. The Little Dumbbell, however, demands darker skies and sharper optics to reveal its delicate structure. Yet the effort is worth it, seeing these nebulae first and connects us to the grand narrative of stellar evolution, where even in death stars create beauty. What's truly remarkable is how these two objects, though linked by name, showcase the diversity of planetary nebulae. One is broad and luminous, the other compact and intricate. Together, they remind us that the cosmos resists simple categorization, always offering surprises to those who look closely. So the next time you hear Dumbbell Nebula, think beyond the name and picture the dazzling, complex reality hidden within. Now, let's journey from the deceptive dumbbells of the cosmos to a celestial spectre that looks like it was torn straight from the pages of a ghost story, the Veil Nebula. This sprawling supernova remnant, catalogued as NGC 6960, is a hauntingly beautiful tapestry of glowing filaments, each one a testament to a star's catastrophic end. Imagine a star many times more massive than our Sun, reaching the end of its life not with a whimper, but with a cataclysmic explosion so powerful it outshone entire galaxies for weeks. That's the violent birth of the Veil Nebula. What makes this nebula so captivating is its intricate, lace-like structure. Through a telescope, it appears as delicate, wispy tendrils of ionized gas, glowing in ethereal shades of red and blue. These filaments aren't just random cosmic debris, they're the result of shockwaves from the supernova blast slamming into surrounding interstellar material at speeds of millions of kilometers per hour. The collision heats the gas to extreme temperatures, causing it to emit light in vivid hues. It's like watching the aftermath of a cosmic tsunami frozen in time. The Veil Nebula is part of a larger remnant known as the Cygnus Loop, stretching over 100 light-years across. To put that into perspective, if you could travel at the speed of light, it would take you an entire human lifetime just to cross a fraction of this structure. And here's the wild part: the explosion that created it happened around 5,000 to 8,000 years ago. That means when early human civilizations were building their first cities, the light from this supernova was already reaching Earth, possibly visible to our ancestors as a sudden, brilliant new star in the sky. What's even more fascinating is how the Veil Nebula reveals the physics of stellar death. The filaments aren't just pretty, they're cosmic laboratories. Astronomers study them to understand how shockwaves propagate through space, how elements forged in the star's core are scattered into the galaxy, and even how magnetic fields shape the remnants. Every twist and knot in those glowing strands tells a story about the forces at play when a star self-destructs. For amateur astronomers, the Veil Nebula is a challenging but rewarding target. Under dark skies, with a good telescope and an oxygen-3 filter, its delicate threads emerge from the blackness like phantom brushstrokes. Some observers describe it as catching glimpses of a celestial spider's web, fragile yet vast. It's a humbling reminder that even in destruction, the universe creates beauty, a ghostly monument to a star's final act. So the next time you look at the constellation Cygnus, remember, hidden among its stars is this breathtaking remnant, a whisper from a cosmic explosion that echoed across millennia. The Veil Nebula doesn't just show us death, it shows us transformation, the endless cycle of matter and energy woven into the fabric of space itself. Now, let's shift our gaze from the ghostly remnants of the Veil Nebula to a celestial illusion that plays tricks on the human eye, the blinking planetary, also known as NGC 6826. This nebula has a peculiar quirk. It appears to blink in and out of view when observed through a telescope, as if playing a cosmic game of hide and seek. But don't be fooled, this isn't some interstellar magic trick. The phenomenon is rooted in the quirks of our own vision. When you first look at the blinking planetary through a telescope, you might see nothing but darkness. But shift your gaze slightly to the side, using your peripheral vision, and suddenly, the nebula pops into view. This happens because the human eye's central vision, which is great for detecting color and fine details, is less sensitive to faint light. Our peripheral vision, on the other hand, excels at picking up dim objects. So when you look away slightly, the nebula's faint glow becomes visible, creating the illusion of blinking. It's a perfect example of how our own biology shapes what we see or don't see in the cosmos, but the blinking planetary isn't just a visual curiosity. At its heart lies a dying star, a white dwarf pumping out intense ultraviolet radiation. This energy lights up the surrounding gas, causing it to glow in vivid greens and blues, a hallmark of ionized oxygen. What's truly mesmerizing, though, are the nebula's fast-moving knots of gas. These aren't just static wisps, they're racing outward at speeds of tens of thousands of kilometers per hour, propelled by the star's fierce winds. Over time, these knots will dissolve into the interstellar medium, scattering the star's remains across space. Astronomers have also noticed something unusual about the nebula's shape. Unlike many planetary nebulae, which are symmetrical, the blinking planetary has a slightly elongated structure. Some researchers suggest this could be due to a companion star, though none has been confirmed yet, or perhaps magnetic fields twisting the outflowing gas. Whatever the cause, it adds another layer of mystery to this already enigmatic object. For amateur astronomers, the blinking planetary is a fun and slightly frustrating target. Its blinking effect can make it tricky to locate, but once you've spotted it, the nebula's subtle glow is a rewarding sight. A mid-sized telescope and a filter that enhances oxygen emissions will help bring out its delicate details. And while it might not be as grand as some of the other objects we've explored, there's something deeply satisfying about outsmarting your own eyes to catch a glimpse of this cosmic flicker. So the next time you're under a dark sky, take a moment to seek out the blinking planetary. It's a reminder that sometimes the universe's most fascinating secrets are hidden in plain sight if you know how to look. And who knows, maybe you'll uncover another of its mysteries waiting to be solved. Now, leaving behind the playful illusions of the blinking planetary, let's turn our attention to a cosmic specter that haunts the night sky. The ghost of Jupiter, officially catalogued as NGC 3242. This planetary nebula earns its eerie nickname not from any supernatural activity, but from its faint, ethereal glow that resembles the giant planet Jupiter when viewed through a telescope. But don't let its ghostly appearance fool you. What we're seeing is the final, breathtaking act of a star's life, playing out on a scale that's both beautiful and humbling. At the heart of the ghost of Jupiter lies a dying star, much like the one in the blinking planetary, but here the drama unfolds with even more grandeur. The star has shed its outer layers, creating concentric shells of gas that expand outward like ripples in a pond. These shells glow in vibrant hues of blue and green, illuminated by the intense ultraviolet radiation from the central star. What's truly captivating, though, are the searchlight beams that shoot out from the star's poles. These narrow jets of ionized gas stretch far into space, as if the star is sending out cosmic distress signals. Astronomers believe these beams are sculpted by powerful magnetic fields or the gravitational influence of an unseen companion star, though the exact mechanism remains a puzzle. The ghost of Jupiter's structure is a textbook example of how complex planetary nebulae can be. Unlike the blinking planetary's elongated shape, this nebula boasts remarkable symmetry, with its glowing shells arranged in near-perfect spheres. Yet, if you look closely, you'll notice subtle irregularities, knots, and filaments that hint at turbulent forces at work. These features suggest that the star didn't eject its outer layers in a smooth, steady flow, but rather in violent bursts, perhaps triggered by instabilities in its final throes. For amateur astronomers, the ghost of Jupiter is a rewarding target, though it requires a bit of patience. Under dark skies, a mid-sized telescope will reveal its soft, circular glow, while larger apertures can bring out the delicate details of its shells and searchlight beams. A nebula filter, which isolates the light of ionized oxygen, will make the view even more striking, and while it might not have the immediate wow factor of some brighter nebulae, there's something deeply moving about witnessing the last gasp of a star frozen in time and space. What makes the ghost of Jupiter particularly fascinating is how it mirrors the fate of our own Sun. In about 5 billion years, our star, too, will exhaust its nuclear fuel and begin shedding its outer layers, creating a planetary nebula of its own. Will it look like the ghost of Jupiter? Probably not exactly. Each star's death is unique, but the underlying process will be the same. In that sense, this cosmic ghost isn't just a distant curiosity. It's a preview of our solar system's distant future, a reminder that even the stars are mortal. So the next time you're under a clear night sky, take a moment to seek out the ghost of Jupiter. It's a celestial masterpiece that blends artistry with astrophysics, offering a glimpse into the life cycles of stars and the fleeting yet spectacular beauty of their final moments. And who knows, maybe you'll be the one to unlock another of its secrets, adding to the ever-growing story of our universe. Shifting our gaze from the ethereal glow of planetary nebulae, we now encounter two cosmic needles threading through the darkness: the Silver Sliver Galaxy, known as NGC 891, and its striking counterpart, the Needle Galaxy, catalogued as NGC 4565. These edge-on spiral galaxies offer some of the most mesmerizing views in the night sky, appearing as delicate slivers of light stretched across the cosmic canvas. But don't let their thin appearances deceive you. Each holds a wealth of secrets in their dust-choked lanes and star-studded disks. First, let's unravel the mysteries of the Silver Sliver Galaxy. When viewed edge-on, NGC 891 looks like a razor-thin streak of starlight, flanked by a prominent dust lane that splits its disk in half. This dark ribbon isn't just picturesque, it's a bustling highway of gas and dust where new stars are born. But what really baffles astronomers is the galaxy's extraplanar gas, vast clouds of hydrogen that stretch far above and below its main disk like a cosmic halo. How did this gas get there? Some theories suggest it was blasted outward by supernova explosions or tugged into place by gravitational interactions with smaller galaxies. Yet, no single explanation fully accounts for its sheer scale, making NGC 891 a tantalizing puzzle. Now, let's turn to the Needle Galaxy, NGC 4565. Like the Silver Sliver, it presents a breathtaking edge-on profile, but with even more dramatic dust lanes weaving through its disk. These lanes aren't just dark smudges, they're dense, cold nurseries where stars ignite, hidden from plain view. The Needle Galaxy's central bulge, a glowing hub of older stars, adds to its elegance, giving it a spindle-like silhouette. What sets NGC 4565 apart is its sheer size. Spanning over 100,000 light-years, it dwarfs many other spirals, including our Milky Way. Its vast disk teems with star clusters and nebulae, though we can only glimpse their collective glow from our vantage point. Comparing these two galaxies reveals both their shared traits and striking differences. Both are textbook examples of edge-on spirals, showcasing the dramatic effects of perspective, their disks flattened into near-invisible lines. Both are riddled with dust lanes, evidence of the raw materials that fuel star birth. Yet, the Silver Sliver's enigmatic extraplanar gas has no clear parallel in the Needle Galaxy, hinting that their evolutionary paths may have diverged in subtle but significant ways. For stargazers, these galaxies are surprisingly accessible. Under dark skies, a modest telescope can reveal their slender forms, though larger apertures will tease out their dust lanes and faint extensions. The Needle Galaxy, in particular, is a favorite among amateur astronomers for its crisp, needle-like appearance. Observing them side by side offers a rare chance to compare cosmic architecture in action, a reminder of how much a galaxy's orientation shapes our view of it. But what makes these slivers of light truly fascinating is what they represent. They're not just celestial oddities, they're mirrors of our own Milky Way, seen from an angle we can never witness directly. By studying their dust lanes, bulges, and halos, astronomers piece together clues about how spiral galaxies evolve, how stars are born, and how gravity sculpts the universe on the grandest scales. So the next time you spot one of these cosmic needles, remember, you're not just seeing a galaxy, you're seeing a chapter in the story of how all galaxies, including ours, came to be. Now, let's turn our attention to a galaxy that looks like it's been hurled through a cosmic car crash, the Whirlpool Galaxy, officially known as NGC 1318. Unlike the delicate slivers we just explored, this galaxy is a sprawling, chaotic mess, its structure warped by a violent collision that sent shockwaves through its stars and gas. If you've ever wondered what happens when two galaxies slam into each other, the cartwheel is your front row seat to the aftermath. At first glance, NGC 1318 resembles a wagon wheel with a bright inner ring encircling its core and a sprawling outer ring that seems to ripple outward like a stone dropped in a pond. But this isn't some elegant design, it's the result of a smaller galaxy plunging straight through its center millions of years ago. The impact sent waves of dense gas and dust rushing outward, triggering a frenzy of star formation along the expanding rings. These starburst regions glow intensely, lighting up the galaxy's twisted skeleton with clusters of young blue stars. The cartwheel's inner ring is particularly fascinating. Packed with newborn stars and superheated gas, it's a stellar nursery on overdrive where stars form at rates hundreds of times faster than in our Milky Way. Meanwhile, the outer ring is still expanding, its shockwave sweeping up material like a cosmic snowplow. But here's the twist, the smaller galaxy that caused all this chaos is long gone, having sailed right through and continued on its journey, leaving behind a wreckage that astronomers are still piecing together. What makes the Whirlpool Galaxy so valuable to scientists is its snapshot-like quality. Most galactic collisions happen over such vast timescales that we only catch glimpses of the process. But here, we're seeing the aftermath at just the right moment after the initial impact, but while the rings are still vibrant and active. By studying its structure, astronomers can trace how gravity and shockwaves reshape galaxies, how starbursts ignite, and how these events recycle the raw materials of the universe. For observers, the cartwheel is a challenging but rewarding target. Located about 500 million light-years away, it requires a sizable telescope to spot its distinct rings. Yet, even in amateur images, its asymmetry and faint outer loops hint at the violence that created it. And while it might look like a celestial oddity now, its story isn't unique. Our own Milky Way is on a collision course with the Andromeda Galaxy, and in a few billion years, the two will merge into something entirely new, perhaps even a ringed galaxy of their own. The Whirlpool Galaxy is more than just a cosmic wreck. It's a living laboratory, a reminder that the universe is anything but static. Every twist of its rings, every burst of star formation, tells us something new about how galaxies evolve, collide, and rebuild. So the next time you gaze at its peculiar shape, remember, you're looking at the aftermath of a cosmic demolition and a preview of what might one day happen to our own galactic home. Now, shifting our gaze to a celestial spectacle that feels almost otherworldly, let's explore the Helix Nebula, catalogued as NGC 7293. Often nicknamed the Eye of God for its hauntingly beautiful spiral structure, this planetary nebula is one of the closest to Earth, lying just about 650 light-years away in the constellation Aquarius. But don't let its proximity fool you. This cosmic eye is anything but simple. At its heart, the Helix Nebula tells the story of a star in its final act. What you're seeing is the outer layers of a sun-like star, violently expelled into space as it runs out of fuel. The star's core, now a white dwarf, glows fiercely with ultraviolet radiation, lighting up the ejected gas in a vivid palette of blues and reds. These intricate coils and loops aren't just random chaos, they're the star's dying breaths frozen in time, sculpted by forces we're still working to understand. One of the most striking features of the helix is its complex structure. unlike the smooth rings of the Ring Nebula, this nebula is a tangled web of filaments and knots, each one a clue to the star's final throes. Scientists believe these knots, often called cometary globules, are dense pockets of gas that survived the star's violent outburst. Each one is larger than our entire solar system, with tails stretching outward like cosmic tadpoles, buffeted by the relentless stellar wind from the white dwarf. Photographing the Helix Nebula is a challenge even for seasoned astronomers. Its glow is deceptively faint, spread over an area nearly half the size of the full moon in our sky. To capture its delicate details, long exposures and specialized filters are a must, isolating the light from ionized oxygen and hydrogen. Amateur images often reveal only the brightest inner ring, but deep space telescopes like Hubble peel back the layers, exposing the nebula's full grandeur, including a faint outer halo that suggests multiple outbursts occurred over thousands of years. What makes the Helix particularly fascinating is its preview of our own sun's fate. In about 5 billion years, our star will shed its outer layers in a similar display, leaving behind a white dwarf surrounded by a glowing nebula. The Helix gives us a front-row seat to this process, offering insights into how planetary nebulae enrich the universe with heavy elements, seeding future generations of stars and planets. For stargazers, the Helix Nebula is a humbling reminder of the cosmic cycle of life and death. Though it requires a telescope to spot, its eerie, eye-like structure makes it a favorite among astrophotographers. And while its nickname might sound dramatic, there's no denying the awe it inspires. A dying star's final masterpiece glowing softly in the vast dark. So next time you look up, remember, the universe doesn't just create. It recycles, transforms, and in the case of the Helix, leaves behind something breathtakingly beautiful in its wake. Now, let's turn our attention to a whirlwind of cosmic chaos, the Southern Pinwheel, also known as NGC 5236. This face-on spiral galaxy, located roughly 15 million light-years away in the constellation Hydra, is a stunning example of celestial turbulence. Unlike the orderly spirals we often picture, the Southern Pinwheel's arms are a frenzy of star formation, twisted and distorted by a violent past. What makes this galaxy so intriguing is its history of collisions. Astronomers believe it once merged with a smaller galaxy, and the aftermath of that cosmic crash is still written across its structure. The gravitational tug of war sent shockwaves through its gas and dust, triggering bursts of new star formation. These starburst regions glow fiercely with young, hot stars, painting the galaxy's arms in vivid blues and pinks. But the chaos doesn't stop there. The Southern Pinwheel is also a hotspot for supernova. In the last century alone, at least 6 of these colossal stellar explosions have been observed here, making it one of the most active galaxies in our cosmic neighborhood. At the heart of this maelstrom lies another mystery, an active galactic nucleus. This is the mark of a supermassive black hole, millions of times heavier than our Sun, feeding on the surrounding material. As gas and dust spiral into the black hole, they heat up to incredible temperatures, emitting intense radiation across the spectrum. Sometimes, this activity can even produce powerful jets, though in the case of the Southern Pinwheel, the black hole's outbursts are more subdued compared to some of its more extreme cousins. Still, its presence adds another layer of dynamism to an already energetic galaxy. For amateur astronomers, the Southern Pinwheel is a rewarding target. Its face-on orientation means we get a nearly unobstructed view of its spiral structure, and under dark skies, even modest telescopes can reveal its brighter regions. But to truly appreciate its intricate details, long exposure photography is key. Advanced images reveal delicate dust lanes weaving between the star clusters, as well as faint tidal streams, ghostly remnants of the galaxy's past merger. The Southern Pinwheel isn't just a spectacle, it's a living lesson in galactic evolution. Its twisted arms remind us that galaxies aren't static islands in space but dynamic, ever-changing systems shaped by collisions, explosions, and the relentless pull of gravity. And as we study its supernova and active core, we gain insights into the forces that drive the universe's most dramatic transformations. So next time you gaze at a spiral galaxy, remember, behind its beauty often lies a history of cosmic violence, and the southern pinwheel is no exception. Now, shifting our cosmic lens, let's zoom in on two of the most dramatic duets in the universe, the antennae galaxies and the mice galaxies. These colliding pairs offer a front-row seat to the violent yet beautiful process of galactic mergers, each telling its own unique story of cosmic chaos and rebirth. First, meet the antennae galaxies, catalogued as NGC 4038 and NGC 4039. Located about 60 million light-years away in the constellation Corvus, these two spiral galaxies have been locked in a gravitational tango for hundreds of millions of years. What makes them so striking are their long, streaming tails of gas, dust, and stars stretched out like the antennae of an insect, hence their name. These tidal tails are the aftermath of their collision, whipped into space by the immense gravitational forces at play. But the real spectacle lies within the galaxy's cores, where the collision has triggered a firestorm of star formation. The antennae are home to some of the most prolific stellar nurseries in the known universe, with countless young star clusters blazing to life in the chaos. Some of these clusters are so massive and dense, they may one day evolve into globular clusters, the ancient stellar relics we see orbiting older galaxies today. Now contrast that with the mice galaxies, NGC 4676, another pair of spirals in the midst of a merger. Found roughly 300 million light-years away in Coma Berenices, the mice are at an earlier stage of collision than the antennae. Here, the galaxies are still connected by long, slender filaments of stars and gas thread-like bridges stretching between them as they slowly twirl toward one another. These delicate structures are a snapshot of the early phases of a merger, before the violent starbursts and tidal tails take center stage. What's fascinating about the mice is how their interaction highlights the subtlety of galactic dynamics. Unlike the antennae's explosive star formation, the mica's dance is quieter, with their long tails serving as a preview of the dramatic changes yet to come. Both pairs hold critical clues about how galaxies evolve. The antennae show us the peak of merger activity, where chaos births new stars at a staggering rate, while the mice offer a glimpse into the quieter, more methodical beginnings of the process. Together, they remind us that galaxy collisions aren't just destructive, they're also creative, sculpting new structures and igniting stellar fireworks. For astronomers, these systems are like cosmic laboratories, revealing how mergers shape the size, shape, and star-forming potential of galaxies over billions of years. And here's a thought to ponder. Our own Milky Way is on a collision course with the Andromeda Galaxy, set to merge in about 4 billion years. When that happens, the spectacle might resemble the antennae or the mice, a reminder that even our galaxy's fate is written in these distant, colliding pairs. So the next time you look up at the night sky, remember, the universe is anything but static. It's a dynamic, ever-changing stage where galaxies waltz, collide, and transform in ways we're only beginning to understand. Now, let's turn our attention to a celestial predator lurking in the depths of space, the Black Widow Nebula, also known as NGC 2070. Nestled within the larger Tarantula Nebula, this eerie cosmic web earns its name from the dark, twisting tendrils of gas that sprawl outward like the legs of a spider. But don't let its ominous appearance fool you. This nebula is far more than just a cosmic arachnid. It's a powerhouse of stellar activity where radiation and stellar winds sculpt the surrounding gas into its haunting shapes. At the heart of the Black Widow Nebula lies one of the most massive star clusters in our galactic neighborhood, R136. This cluster is a gathering of stellar giants, some weighing in at over 300 times the mass of our Sun. These behemoths flood their surroundings with intense ultraviolet radiation and powerful stellar winds, carving out vast cavities in the nebula's gas and dust. The result is a landscape of glowing filaments and dark, wispy tendrils, creating the illusion of a spider's web woven across the cosmos. What makes this nebula so fascinating is how it showcases the delicate balance between creation and destruction. The same radiation that tears the gas apart also lights it up, producing the nebula's ghostly glow. But the Black Widow Nebula isn't just a pretty sight. It's also a crucial laboratory for understanding how massive stars influence their surroundings. The stars in R136 are so luminous, they're literally blowing bubbles in the gas around them, shaping the nebula's structure over thousands of years. Some of these bubbles will eventually rupture, allowing the radiation to escape and triggering new waves of star formation in neighboring regions. It's a cycle of birth and destruction that plays out across the universe, and here in the Tarantula Nebula we get a front-row seat. What's even more intriguing is the Tarantula Nebula's role as the most active star-forming region in our local group of galaxies. This makes the Black Widow Nebula a key piece of the puzzle in understanding how stars form in extreme environments. If you've ever wondered where the universe's most massive stars are born, look no further. NGC 2070 offers a glimpse into the chaotic, radiant cradles where these cosmic giants take their first breaths. So next time you gaze up at the night sky, remember, even the darkest corners of space are alive with activity. The Black Widow Nebula might seem like a silent predator, but in reality, it's a vibrant, dynamic region where stars are born, live out their fiery lives, and leave their mark on the cosmos. And who knows, somewhere in those tangled tendrils of gas, the next generation of stellar titans is already taking shape. Now, let's shift our gaze to a cosmic masterpiece that defies the usual chaos of space, the Red Rectangle Nebula, or NGC 7027. Unlike the tangled webs of the Black Widow, this nebula is a stunning example of symmetry in the universe, earning its name from the striking, almost perfect rectangular shape that glows with vivid hues of red and orange. But what makes this nebula truly extraordinary isn't just its appearance, it's the secrets hidden within its geometric elegance. At the heart of the red rectangle lies a binary star system, where two stars orbit each other in a delicate dance. One of these stars is a dying red giant, shedding its outer layers into space, while its companion, a hotter, younger star, bombards those ejected layers with intense radiation. This cosmic partnership creates the nebula's unique structure. As the red giant's material flows outward, it collides with the younger star's energy, sculpting the gas and dust into that unmistakable rectangular shape. But here's the twist. The nebula isn't actually a perfect rectangle. Instead, it's a complex series of concentric rings and spikes, like ripples in a pond, giving the illusion of sharp angles when viewed from Earth. What really sets the red rectangle apart, though, is its chemistry. This nebula is a cosmic laboratory for some of the rarest molecules in space. Scientists have detected exotic compounds like polycyclic aromatic hydrocarbons, essentially giant carbon-based molecules floating within its glowing gas. These molecules are thought to be the building blocks of more complex organic materials, possibly even the precursors to life. The vivid red glow, that's the light emitted by these very molecules as they're energized by the binary star's radiation. It's as if the nebula is painting its own portrait with the brushstrokes of interstellar chemistry. But the mysteries don't end there. The red rectangle also boasts a pair of towering searchlight beams shooting from its core. These are streams of gas and dust ejected at high speeds by the binary system, and they're illuminated by the star's intense light. Some researchers believe these beams could be the early stages of a planetary nebula, a final farewell from the dying red giant as it transforms into a white dwarf. If that's the case, we're witnessing a fleeting moment in cosmic time, a snapshot of a star's transition into its twilight years. What makes NGC 7027 so captivating is how it challenges our expectations. Most nebulae are chaotic and irregular, but here we have one that's almost unnaturally precise. It's a reminder that the universe loves variety, and even in the vastness of space, there's room for both chaos and order. So the next time you picture the cosmos, remember, somewhere out there, a dying star and its companion are crafting a masterpiece, one molecule at a time. Moving from the geometric wonders of the red rectangle, we now turn our attention to a celestial enigma that seems almost too perfect to be real. Hoag's object, catalogued as NGC 6028. This bizarre ring galaxy is one of the most peculiar sights in the cosmos, a nearly flawless circle of young, blue stars orbiting an ancient yellow core, separated by a dark, seemingly empty gap. It's as if someone took a classical spiral galaxy, removed its arms, and left behind only a halo of starlight. The sheer symmetry of Hoag's object is so striking that when astronomer Arthur Hoag first discovered it in 1950, he initially thought it might be a trick of the light, a cosmic mirage. But no, this ring is very real, and its origins remain one of astronomy's most tantalizing puzzles. So how does a galaxy like this come to exist? The leading theory suggests a violent collision. Imagine another galaxy plowing straight through the center of Hoag's object billions of years ago. The gravitational shockwave from that impact could have scattered stars outward, leaving behind a dense core while triggering star formation in an expanding ring around it. Supporting this idea, astronomers have spotted other ring galaxies with similar structures, many of which show clear signs of past collisions. But here's the catch: Hoag's object shows no evidence of a recent crash. There's no visible companion galaxy nearby, no twisted debris trails, no telltale signs of galactic wreckage. If a collision did happen, it was so clean and precise that it left behind no trace, which seems almost impossible given the chaotic nature of such events. This leaves us with a far more intriguing possibility: that Hoag's object formed this way naturally, without any cataclysmic intervention. Some researchers propose that instabilities in the galaxy's original gas disk could have caused it to fragment into two distinct zones: a stable core and a rippling outer ring where stars began to form. Others suggest that the gravitational influence of an unseen dark matter structure might have sculpted the ring over eons. But these explanations are speculative at best, and none fully account for the galaxy's near-perfect circular symmetry. Even more baffling, peering through the gap between the core and the ring, astronomers have spotted yet another, fainter ring galaxy in the distant background, a cosmic coincidence that only adds to the mystery. What makes Hoag's object so captivating isn't just its strange beauty, it's the way it forces us to question our assumptions about how galaxies evolve. Most galaxies fit neatly into categories like spirals, ellipticals, or irregulars, but Hoag's object defies them all. Is it a freak accident, a rare survivor of some forgotten cosmic event? Or is it a sign that the universe has more tricks up its sleeve than we've yet imagined? For now, this celestial oddity remains a reminder that even in the vast, well-mapped reaches of space, there are still wonders that leave even the brightest minds scratching their heads. And who knows, maybe the next time we peer into the abyss, we'll find another perfect ring staring back at us, waiting to unravel its secrets. Now, shifting our gaze to another cosmic puzzle, we encounter the enigmatic NGC 1277, a galaxy that astronomers have dubbed a relic of the ancient universe. Unlike most galaxies which evolve and change over billions of years, NGC 1277 appears frozen in time, a snapshot of the early cosmos preserved with startling clarity. But what truly sets this galaxy apart is the monstrous secret lurking at its heart. A supermassive black hole so colossal that it challenges everything we thought we knew about how galaxies and black holes grow together. At the center of NGC 1277 lies a black hole weighing in at a staggering 17 billion times the mass of our Sun. To put that into perspective, the supermassive black hole at the core of our own Milky Way, Sagittarius, a star, is a mere featherweight in comparison, clocking in at around 4 million solar masses. The sheer size of NGC 1277's black hole is so extreme that it makes up roughly 14% of the galaxy's total stellar mass. That's like finding a bowling ball inside a grape. It defies all expectations. According to current theories, black holes and their host galaxies are supposed to grow in tandem, with the black hole typically accounting for only about 0.1% of the galaxy's mass. But NGC 1277 blows that rule out of the water, forcing scientists to rethink the relationship between these cosmic giants. How could a black hole grow so disproportionately large? One possibility is that NGC 1277 is a failed galaxy, a relic that stopped evolving billions of years ago. In the chaotic early universe, galaxies were smaller and denser, and black holes may have grown rapidly by feasting on the abundant gas around them. Most galaxies then merged with others, diluting their central black hole's dominance over time. But NGC 1277 somehow avoided these mergers, leaving its black hole frozen in its ancient, oversized state. This would make it a rare living fossil, a window into a time when the universe was young and black holes ruled with unchecked might. Yet this explanation raises even more questions. If NGC 1277 is truly a relic, why does it look so ordinary? Its structure is smooth and elliptical, lacking the messy scars of violent mergers, and its stars orbit in an orderly fashion, unlike the chaotic motions seen in other ancient galaxies. Some researchers argue that its black hole might have grown not through mergers but through some unknown, extreme process, perhaps a runaway collapse of gas directly into the center, bypassing the usual limits. Others suggest that our models of black hole growth might simply be incomplete, missing a key piece of physics that allows black holes to balloon to such outrageous sizes. The implications of NGC 1277 ripple far beyond this one galaxy. If its black hole isn't a freak accident but a sign of a forgotten chapter in cosmic history, then our understanding of galaxy evolution might need a major rewrite. Could there be other relics like it hiding in plain sight, their black holes silently defying the rules? And what does this mean for the supermassive black holes we see in galaxies today? Could they have grown much faster in their youth than we ever imagined? NGC 1277 doesn't just challenge the textbooks, it forces us to confront how much we still don't know about the forces that shape our universe. As we continue to probe the depths of space, galaxies like this remind us that the cosmos is full of surprises, places where the rules bend, theories crumble, and the only certainty is that there's always more to discover. Perhaps the next time we train our telescopes on the night sky, another relic will reveal itself, offering fresh clues to the untold stories of the universe's past. Now, let's turn our attention to a celestial loner that defies expectations, the mysterious globular cluster NGC 2419, often called the intergalactic wanderer. Unlike most globular clusters that orbit close to the Milky Way's core, this one roams the distant fringes of our galaxy's gravitational grasp, sparking debates about where it truly came from. Is it a lost traveler from another galaxy, or a survivor of our own galaxy's violent past? NGC 2419 lies an astonishing 300,000 light-years from Earth, so far out that it skirts the boundary between the Milky Way and intergalactic space. For comparison, most globular clusters, like the famous M13, orbit within 25,000 light-years of the galactic center. But this wanderer moves at such a distance that it takes nearly 3 billion years to complete a single orbit around the Milky Way. That extreme isolation raises a tantalizing question. Did it form with our galaxy, or was it snatched from another? One clue lies in its composition. NGC 2419 is packed with ancient stars, some nearly as old as the universe itself, but they contain unusual chemical signatures, many of its stars are richer in helium and nitrogen than typical Milky Way globular clusters, yet poorer in elements like oxygen and magnesium. This peculiar mix suggests it might have originated in a dwarf galaxy that was torn apart by the Milky Way long ago. When small galaxies collide with larger ones, their star clusters can be ripped away and left adrift cosmic orphans wandering the outskirts of their captor. But here's the twist. NGC 2419's orbit doesn't neatly match the paths of known galactic wreckage, leaving astronomers puzzled. Could it have come from a galaxy we haven't discovered yet? Another theory proposes that NGC 2419 might actually be a relic of the Milky Way's infancy. In the chaotic early universe, our galaxy likely formed from the mergers of smaller protogalaxies. Some of their clusters could have been flung outward during these violent encounters, ending up in distant, looping orbits. If true, this wanderer could be a time capsule from the Milky Way's birth, preserving secrets about how giant galaxies assemble. Yet its unusual chemistry still doesn't perfectly align with other ancient clusters native to our galaxy, keeping the debate alive, the most radical idea. That NGC 2419 isn't bound to the Milky Way at all. Some simulations suggest it could be a rare, free-floating globular cluster drifting through intergalactic space on a solo journey. These rogue clusters are thought to exist, ejected from their home galaxies during cosmic collisions, but none have been definitively confirmed. If NGC 2419 is one, it would rewrite the rules of how star clusters survive and where they can call home. What makes this enigma so compelling is that it challenges our assumptions about cosmic belonging. Most objects in the night sky fit neatly into categories: galaxies, clusters, nebulae. But NGC 2419 blurs those lines, forcing us to ask whether it's truly part of our galaxy, a captured intruder, or something else entirely. Future telescopes, like the upcoming Nancy Grace Roman Space Telescope, may finally trace its origins by mapping the faint trails of stars around it, hints of a past collision or escape. Until then, the intergalactic wanderer remains a cosmic riddle, reminding us that even in the vastness of space, some objects refuse to be neatly labeled. As we piece together its history, we're not just solving one cluster's mystery, we're uncovering clues about how galaxies grow, interact, and sometimes let go. And that's a story written across the entire universe. Now, let's shift our gaze to another cosmic oddity, NGC 5128, better known as Centaurus A. This peculiar galaxy stands out for its dramatic, jagged dust lane slicing across its center like a scar. It's a striking visual, but this dark gash isn't just for show. It's the aftermath of a galactic collision, a violent event that reshaped Centaurus A into the chaotic masterpiece we see today. Centaurus A is what astronomers call a peculiar galaxy, a label reserved for systems so bizarre they defy standard classifications. At its heart lies a supermassive black hole, but unlike the quiet giants in most galaxies, this one is hyperactive, spewing jets of plasma at nearly half the speed of light. These jets stretch for millions of light years, making them some of the largest structures in the universe. But what really steals the show is that thick, twisting dust lane, a debris field from a past merger. Around 10 million years ago, Centaurus A was likely a normal elliptical galaxy, a smooth collection of old stars. Then it cannibalized a smaller spiral galaxy. The collision sent shockwaves through both systems, shredding the spiral's gas-rich disk and scattering it into the chaotic lane we see today. The dust isn't just passively floating, it's being funneled toward the black hole, fueling its monstrous appetite. This ongoing feast powers the galaxy's colossal jets, which glow in radio waves and X-rays. What's even wilder is that Centaurus A's chaos isn't confined to its core. The merger triggered a starburst frenzy, with newborn stars igniting across the galaxy. Meanwhile, the black hole's jets have blown bubbles of hot gas into intergalactic space, creating shock fronts that heat surrounding material. It's a galaxy-wide demolition derby where gravity, radiation, and magnetic forces battle for dominance. Yet Centaurus isn't just a spectacle, it's a clue. Its messy aftermath helps astronomers understand how mergers transform galaxies. Most ellipticals are smooth and red and dead, their star-forming gas long gone. But Centaurus proves that even these aging giants can be reignited by collisions. Its dust lane is a time capsule, preserving the moment it swallowed its neighbor. Future studies aim to map the debris in finer detail, tracing how the spiral galaxy's remains were shredded and absorbed. Each clue brings us closer to decoding the life cycles of galaxies, how they're born, how they evolve, and how sometimes they're reborn in chaos. Centaurus reminds us that even in the seemingly serene universe, violence and beauty often go hand in hand. From the haunting glow of the Black Eye Galaxy to the perfect ring of Hoag's object, we've journeyed through 25 of the most bizarre and breathtaking celestial wonders in the NGC catalogue. Each of these objects tells a story, some whisper of violent collisions, others hum with the eerie light of dying stars, and a few defy explanation entirely. What unites them is their ability to remind us just how strange and beautiful the universe truly is. Take the Sombrero Galaxy, with its enigmatic halo stretching far beyond what our theories predict, or the Veil Nebula's delicate filaments, remnants of a star's final cataclysmic scream. Then there's Centaurus A, a galactic Frankenstein, its dark dust lane a testament to the chaos of mergers. And who could forget NGC 1277, a relic galaxy with a black hole so massive it appends everything we thought we knew about cosmic evolution. These objects aren't just curiosities, they're puzzles, challenging us to rethink the rules of physics, the life cycles of galaxies, and even the fate of our own Milky Way. Yet for every mystery we've uncovered, a dozen more remain. Why does the red rectangle nebula glow with such geometric precision? Is Hoag's object a cosmic fluke or a sign of processes we've yet to discover? And what secrets lurk in the distant orbits of globular clusters like NGC 2419, the so-called intergalactic wanderer? The more we learn, the clearer it becomes. The universe thrives on the unexpected. So tonight, if you step outside and look up, remember, you're not just seeing stars. You're glimpsing the same wonders that have baffled and inspired astronomers for centuries. Whether you're spotting the Andromeda Galaxy with binoculars or simply marveling at the Milky Way's arc, you're part of that grand tradition of cosmic curiosity. If these deep space oddities left you as awestruck as they did us, don't miss out on more celestial adventures. Hit that subscribe button and ring the notification bell so you never miss a journey into the unknown. After all, the universe is vast and its mysteries are endless. Who knows what we'll explore next? Until then, keep looking up. You never know what might be staring back.